Okay, good morning, dear students. Today we will learn about the linear differential equation with constant coefficient. First, we need to understand what is the linear differential equation of with the constant coefficient. This the general equation for these type equation is this: d to the power ny upon dx square dx to the power n plus a1 d to the power n minus 1 y upon dx to the power n minus 1, and so on. We have it is a and y, it is equal to x. In this equation we have the degree of every terms of this equation is 1. So this is the linear differential equation and the order is n. Okay, and all the coefficients, this coefficient is a1, this is a2, this coefficient is 1, and so on. This coefficient is an, all are the constant coefficient, and this function in the right hand side, this function is the function of x. Okay, so according the behavior of this equation, we can say that this equation is a linear differential equation with constant coefficient. Now, for solving these type differential equation, first we need to understand the general solution of this type differential equation. The general solution of this type differential equation is, always we can calculate the general solution of this type differential equation using the complementary function plus particular integral. Okay, in this lecture, first we understand about the complementary function and the rules for calculating the complementary function of this type differential equation. This is the first step. This is the first step for finding the complementary function. First we write this equation in the form of auxiliary equation. Okay, in the form of auxiliary equation. This equation is known as auxiliary equation. Auxiliary equation. Okay. Now, in this equation, we can put the d over dx equal to m. So this equation convert in the form of m is like this: m to the power n plus a1 m to the power n minus 1 and plus dot dot so on an, and y, we can take y outside of this bracket, and in right hand side it is equal to 1, it is equal to 0. Okay, and only for finding the complementary function we can do this. Okay, and for finding the particular integral we can use the right hand side function. Okay, now this is the auxiliary equation, and when we find the roots of this auxiliary equation, okay, after solving this equation we can find the roots of this equation, and then after finding the roots we can decide and we can find the complementary function. Now we have four cases for finding the complementary function using the roots of this type polynomial. First case is when the roots are real and different, when the roots are real and distinct. Okay, suppose after solving this equation, suppose this is equation number 1. When we solve this equation and we have the roots are different and real, suppose the roots are m1, m2, m3 and dot dot so on mn. Suppose that we have these are the roots of this equation, and all are different and real. These are the real roots. Then the answer of this equation is, then the complementary function of this equation is, basically we have n, because we have the n roots, so we have n linearly independent solution of equation number 1. Okay, and we can write the complementary function. It's mean we have the n linearly independent solution like this: e to the power m1x, this is the e to the power m2x, similarly this is e to the power m3x and e to the power mnx. Okay, we have the n linearly independent solution. Now we can write the complementary function of this equation is, it is equal to c1 e to the power m1x, c2 e to the power m2x, c3 e to the power m3x, and plus dot dot so on cn e to the power mnx. Okay, this is the equation with the nth order. So we have the n constant in the complementary function. Now the case second is, in the case second we can simply solve the case second when we have the roots are real and same. Suppose that we have the two and more than two roots are same. Second case is case second. In this case, if roots are real and equal. Okay, in this case if we have the roots are real and equal, then we can simply find the complementary function like this. Suppose that we have two roots are equal. Suppose we have two roots are equal, m1 equal to m2 equal to m3. Suppose that we have two roots, m1 equal to m2 equal to p, and other are distinct. Then we can write and other roots are m3, m4 and dot dot so on mn. But we have only two roots are equal. Then the complementary function of this equation is, it is equal to c1 plus c2x for equal roots. For these two equal roots, c1 plus c2x e to the power px. Okay, plus the other roots are linearly independent. Only two roots are dependent, so we can write the dependent roots like this, c1 plus c2x, and other roots are linearly independent. So other roots we can write, this is a c3 e to the power m3x plus c4 e to the power m4x and plus dot dot so on. Okay, and finally cn e to the power mnx. Okay, in this case when we have three roots are equal, if we have three roots are equal, then we can write it c1 plus c2x plus c3x square and e to the power px. When we have three roots are equal, then we can write it c1 plus c2 plus c3x c3x square plus e to the power px and e to the power px and plus dot dot plus c4 e to the power m4x and so on. Okay, similarly when we have more than two roots are equal, like this, when we have more than two roots are equal, suppose that we have more than two roots are equal, more than three roots are equal. Okay, now suppose that m1 equal to m2 equal to m3 equal to m4 equal to p. Okay, and if we have four roots are equal, then we can write the complementary function is c1 plus c2x plus c3x square plus c4x to the power 3 and e to the power px and plus other roots, if other roots are distinct. Okay, now the next case is if the roots are complex. Next case is if the roots are complex. If we have the roots are complex, next case is if we have the complex roots. Case third, if we have complex roots, suppose that the complex roots of this equation, suppose the degree of this equation is 2, and if we have the degree of the equation is 2, then the complex root is, suppose complex roots of this equation is alpha plus minus iota beta. Okay, now we can write the complementary function for this type equation is c1 we can write this complementary function is e to the power alpha x c1 cos beta x plus c2 sin beta x. Okay, suppose that we have more than two complex roots. Okay, more than one complex root, more than two complex roots. Suppose that the complex roots are alpha 1 plus minus iota beta 1 second is alpha 2 plus minus eta beta 2, and suppose that we have the four complex roots. Then we can write the complementary function, that is equal to e to the power alpha 1 x and alpha 1 x c1 cos beta 1 x plus c2 sin beta 1 x, okay, plus e to the power alpha 2 x c3 cos beta 2 x plus plus c4 sin beta 2 x, okay. Okay, now this is the complementary function for four complex roots. Okay, similarly, if the two complex roots are same, in this in the complex roots we have the next case is if we have two complex roots are same, suppose that we have the complex roots are alpha plus minus eta beta, and other complex root is same complex root is alpha plus minus eta beta. Okay, we have the four roots, but in pair we have two complex roots are same. Then the complementary function is e to the power alpha x c1 plus c2x cos beta x plus c3 plus c4x plus c4x sin beta x, right? So this is the complementary function for complex roots. Now another types roots are short roots. Another types roots are short roots. Suppose that in case we have the roots are short roots, means if we have the roots in the form of m1 equal to alpha plus root beta and m2 equal to alpha minus root beta, okay, suppose that we have the roots in the form of this, then the answer of this question is the complementary function of this question is e to the power alpha x, okay, and c1 cos hyperbolic x root beta plus c2 sin hyperbolic x root beta, okay. In this case, this is the complementary function for this equation. Okay students, in our next lecture we will learn the steps for solving the linear differential equation with constant coefficient, and we will find the complementary function for such type differential equation. Okay, thank you.